we said we need to do a graph, and to do this graph they already told us what our scale would be. So they said we're using 1 centimeter to represent 1 unit on both of the axes, right? So 1 pumpkin, 1 melon. So on our x-axis we're talking about pumpkins, number of pumpkins, and on our y-axis we're talking about number of melons. So we just need to remember that, right? So yeah, I should have used a bigger grid, but anyway, so the idea is just to do the typical things you used to do. 1 centimeter representing 1 unit, rule up your axes like you usually would, labeling every 1 centimeter with 1 unit. So this might be a while. Please bear with this language. Alright. So if you have graph paper, like I was saying, or even if you're just sketching, this is the idea. You're starting to do your graph by setting up your axes. Once you set up your axes, then we're going to talk about those inequalities. And if you think you remember how to do your inequalities on a graph easily, just go right ahead and represent the first 2 conditions. Your very first condition from the problem, which we had y is greater than or equal to 3. So you could go ahead and do that. Represent it on the graph. And we'll talk about what you get. Inequality. The inequality is y is greater than or equal to 3. So we're looking at this inequality. Y greater than or equal to 3. Alright? So that's the inequality. So that's the first one you want to put on your graph. And once you do that, we'll move to the second one. So I'll do this, alright? So for my y greater than or equal to 3, I'll use this yellow color, nice and visible. For my second condition, which is y is less than or equal to x, I'll use a different color. I'll use green. And for our third and final inequality, I'll use x plus y less than or equal to 12 as blue. Okay, so time to put them on a graph. When we deal with our inequalities, we had a little thing we needed to recall. We needed to remember that each of these inequalities has an associated linear equation. So if you could remember those, you'd be able to identify where you draw that line, because that is the important part. That is the most important part in being able to identify the region corresponding to your inequality. So y greater than or equal to 3. Anybody here recalls what is the associated linear equation with this inequality? Lovely. Y is equal to 3. Alright, so this is the line that we're going to draw in our graph space now. So I'm going to identify where y is equal to 3, and from there I will then identify the region corresponding to my inequality. Alright, so this is where y is equal to 3. I'm going to write that in. Right, so we have y is equal to 3. And when I talk about y being greater than or equal to 3, where is that going to be in my graph space? Y greater than or equal to 3. Anybody? Where would everything above 3? We all agree with that? Everything above 3 corresponds to y being greater than or equal to 3. That's correct. All right. And even if you were doubtful, you didn't think that that was true, you could test it out. Right? Choose any random point above the line y is equal to 3 and choose any random point below the line y is equal to 3 and look at the y coordinate of that point. So for example, if I choose a point above, let's say I choose a point over here, this might correspond to what? I choose some of the most really 13, 14, 15, 16, 17, 18, 19, 20. Alright, so yeah, this is 28, alright? I choose one of the most arbitrary points I can choose. Okay, let me make my life easier. And let's say I choose a point here now. This would be 12, 1. Alright, comparing the y coordinates would help us with identifying whether or not we were correct. So here I see that I have a y coordinate of 8 versus a y coordinate of 1. And this here tells me that above the line is the correct place to shade, simply because my y coordinate is larger above the line than it is below the line. Alright, so you can test out your regions if ever you're doubtful. Test out your regions and you'll be able to get it. So from here now, we're going to move on to the second inequality, which says y is less than equal to x. And we're going to do the same thing we did earlier. We're going to get that associated linear equation with this inequality. So what would be our associated equation? Y is equal to what? That's it. Y is equal to x. And when you think about the line y is equal to x, it's this wonderful little straight line that passes through the origin. And every single point on this line, the x and y coordinates would be equal to each other. So it looks a lot like this. Is a nice straight line. So I'll stop somewhere here. Like that. Alright? So this is my line y is equal to x. And I need to do... Oh goodness, I used the wrong color. Right, so this is the straight line. Right, so I have y is equal to x, and what I need to do from here is identify the region corresponding to the inequality. Now the inequality says y has to be less than or equal to x. So we already know where y is equal to x, but where do you think would be less than? So where do you think y would be less than or equal to x? So this one's a little bit tricky, alright? But you could do it in more or less the same way you did the previous one, alright? You could test it out by choosing two random points and see where is the y coordinate larger than the x coordinate, and that will help you with identifying which region should be shaded. Okay, so let's do that. I have the line y is equal to x. Let's choose some random point. So if we choose a random point like over here now, the coordinates of this point would be 8, 12. And let's choose a random point like somewhere here now. And the coordinates of that point would be 12, 7. Okay, so compare the coordinates, y'all. Which one do you notice has a larger x coordinate? That's what you want to figure out, because that will tell you where the region needs to be shaded. Alright, so your key here, you want to identify where is y less than or equal to x, or the other way around, where is x greater than y? Where is x greater than y? So you have two ways of looking at it. So compare the coordinates of the points, right? So if I look at 8, 12, which coordinate is larger? Is the x coordinate larger than the y coordinate, or is the y coordinate larger than the x coordinate? Lovely. The y coordinate here is larger than the x coordinate. So does that correspond to the inequality that we want to shade? No, it doesn't. So that means we should shade which direction? Above the line or below it? Below it. That's it. So we're going to shade downwards. Alright? So I'll just erase the two little points. But you see how being able to read off points from your graph and being able to interpret your inequalities, it makes your life a little bit simpler rather than having to guess is it above or below just by looking at it, right? Some people are very good at identifying those things visually, and that's good. But there are others of us, we need some sort of logical process to kind of identify what we need to do. All right, so right now we have our y is less than or equal to x, we have our y is greater than or equal to 3. Now for the tricky one, which is the x plus y less than or equal to 12. X plus y less than or equal to 12, first thing we're going to do is the same thing we did before, associated linear equation. So what is the associated linear equation? That's it. That's all you're doing, right? X plus y is equal to 12. And lastly, like I was saying, you have options. You could either put this in the form y is equal to mx plus c, and then try to set up a table of values and be able to, get some points to plot, or we could shortcut it, right? Everybody, when they're doing maths problems, obviously, they would love a shortcut to solve the problems. So we'll do that. And the shortcut is like this. I had asked you all to recall the intercepts of a linear graph. Alright? So when we talk about linear graphs, we talk about straight line equations like these. We talk about them being able to cut an axis at some point in time. Some graphs might cut an axis only at one point. I should say that better. Some graphs only cut one axis, so they either only cut the y-axis or only cut the x-axis, and that's what we're talking about, linear graphs in particular. But then there's these types of graphs where they could cut both the x and y axes. So to figure out where the graphs cut the axes, we need to know what happens at those particular points. So if I talk about the y-intercept, I'm talking about where does my graph cut the y-axis? And I don't know if you all can recall when I was asking what happens when the graph cuts the y-axis, and specifically, what do you observe as the x-coordinate of the y-intercept? What do you observe as the x-coordinate of the y-intercept? So if you can remember the y-intercept is any point where a graph cuts the y-axis. And on the y-axis, obviously you have values for y because this is your vertical axis. The x-coordinate will always be 0 because you're cutting the y-axis. Alright? So if ever you're asked about the y-intercept, always remember the x-coordinate of a y-intercept is 0, and the y-intercept will be whatever y-coordinate where your graph is cutting it. The x-intercept works in as much the same way. It's just that this time your graph is cutting your x-axis, and since it's cutting the horizontal axis, you will not have a y value that is greater than 0, right? So on your x-axis, your y coordinate will be 0, and those are the two easiest points to pull on a line so that you'll be able to draw the graph without all the headache of choosing values and setting up a table of values and getting coordinates and ordered pages to plot. So we're going to do a shortcut way. Alright, and as I was saying, when we set so when I set x to be 0, I want to get the y value that corresponds to that. So take the 0, substitute it into your equation and see what you get for the value of y. So anybody wants to tell me, when you plug in x is equal to 0, what you get for y? 12. Yep, lovely. So that's why I say the intercepts are such an easy set of points to work with, right? One is 0 and the other would be non-zero, and it makes your life so much simpler. Your y-intercept is 12 for this particular line, right? Your y-intercept is 12. Then, if we want to get the x-intercept, we said that at the x-intercept, our y-coordinate is going to be 0. So we're going to do the same thing that we just did, but this time you're plugging in 0 where y is. So when we substitute that y is 0, what will we get for x? 12. I know, this one seems so simple, and you would probably wish that every single linear programming problem could be as nice and easy as this is, because you have 2 points which lie on the line x plus y is equal to 12. No big set of headache to get them, and now all you have to do is plot them and you'll be able to get the graph. Alright, so we're going to plot these 2 points, 0, 12 and 12, 0. So when x is 0, we said that y is 12, so that's over here. And when x is 12, y is 0. And all I do from now is connect these 2 points with a straight line. And I have my graph for x plus y is equal to 12, right? So we just created a line, x plus y is equal to 12. Alright, but we want to identify a region because we want an inequality to be represented here. Okay, so x plus y is equal to 12 is the blue line, and we said that x plus y cannot exceed this 12. So if it cannot exceed 12, it's telling us that we have to stay less than 12, less than or equal to 12. So which region do you think we should shade? Which region do you think we should shade? X plus y less than or equal to 12. And again, same thing works where you could identify a point above the line and below the line and use your inequality information to help choose. Alright, so we'll do that. Let's select a point above the line. So let's go with this point. Alright, so here the coordinates of this point would be 410. And then we'll go below the line and choose a point. So let's say a point like this one. So this one is 4, 5. Alright, so to figure out which region we need to shade, I want you to add the x and y coordinate values. So if we look at 4, 10, when we add 4 and 10, what do we get? 14. And is 14 less than 12? There we go, it's more than 12. So this tells us already that above the line will not satisfy our inequality. Alright, because we're getting a value that's greater than 12. But if we test 4, 5 now, do the same thing, add up the 2 values. We add 4 and we add 5. What do we get? Do we get a value less than 12? Yeah, you get a 9. See? And 9 is less than 12. So all you have to do now is just shade below the line. So shade below the line now, and we'll talk about the rest of it in a little bit. Alright, so blue arrow to show that we are shading below this line. Alright, this direction. Right, so in the midst of all the colors, right, what I want you also to take note of is this. I don't know if you all would have realized it before, but do you all notice that the lines form a shape where they all sort of cross each other? So the three, there you go. So those three inequalities, when we did the linear equations associated with them, these three lines intersected one another, right? And for this particular problem, it creates a triangle. Now, when it comes to linear programming, like I was saying, we need to get solutions. And where the solutions come from, this particular little region, all right? So it's called a feasibility region. And within that feasibility region, saying rubbish, within that feasibility region will come all your solutions to your problem. And why I call it a feasibility region, this tells you all those possible solutions, all right? Within the confines of this triangular shape, you can get any point that could give you an ideal solution to your problem, right? It will satisfy all the inequalities and you'll get what you want. But depending on the nature of the problem that you're looking at, the points that I highlighted here, the red dots, those 3 points could either maximize or minimize a problem. So in the case of, let's say I was saying last week, week before, sorry, the one with the jerseys and the shirts, if you're getting into business, obviously the purpose of getting into business is to make a profit. So if you're selling back items, you'll want to maximize your profit, all right? In the case of being a supplier of items as well, you want to maximize the amount of items you can produce. And in this case, we're looking at another type of maximization problem. So the points that highlighted on the feasibility region could possibly maximize your solution. Okay, so the coordinates of these points would be very important. And to go back to the problem now, we'll go back to it and see what they want us to do. So we've plotted the graph with all the inequalities, and we've also identified the region that could possibly hold the solution to our problem. So we'll come back to this in a little bit. Let's go look at the problem again.